Assalamu alaikum, welcome to the channel. Today we are going to implement a stack using the Python language. Well, first of all, we will look into an overview of what stack is. Well, stack work on mechanism of last in first out. What does that mean is that whatever value inserted at the last will be retrieved first. So if we draw a visual representation of a stack, then we will see that if we insert a value like this has been a value like 3, and then we if we insert another value, the upcoming value will store on the top of the value that has been already stored. For example, if I insert on another value like 1, then it will store on the top of the value that has been already stored. So on and so forth, the value upcoming values will be stored on the top of the value that had been already stored. So for example, if I have stored 2 here, so it's look like C, but it's 2. So on the retrieving side, when we want to retrieve a value, the top value will be retrieved first. The top value is the value that has been inserted on the last, so it has been retrieved first. So first this will be retrieved, then there is a function which is called pop. What this will do, this will remove the value, whatever value on present on the top. So for example, if I call the pop function, then 2 will be removed, then the top will be pointing to this one, and then this value will be retrieved, and then the pop function will remove the this value, and then top will be pointing to this value, and so on and so forth. If we have so on preceding values, then the same mechanism, pop and top, will be proceeding. So there are two ways to implement the stack. First is array base, and second is linked list base. So in this video we are going to implement the array using the linked list base. So what linked list is, linked list basically has two parts. First part is data part, and then next part is the linking part. What this linking part do is this link the this is a linked list. Basically this is a node containing two parts. First one is value part, and then there is a next pointer, and what this do is this is pointing to the whole next node that has been present in the program. So it has been pointing to the this next array and this next node, sorry. So this will have two parts as well. First part is the value part, then the next uh, part it also has. So this will do the same. This will use to link this one to the next node we have in our program. So this is the mechanism of linked list. There are two parts. First one is the data part. This part will store the data. For example, if I have the data like 2, 1, and 3, and this next part is pointing to none. This point is pointing to none. So this is the linked list. It has two part. Was first part is the data part, which stores the data, and then the next part stores the address of the next node present in the program. So in this way, this is a type of linked list. This list has been linked through a next part. The next part holds the address of this next node, and then this one holds the address of the next node, and so on and so forth until we have the null value. So now we will come up to the implementation part. Like so, I have shown you that the stack implementation using the linked list part will have a node class as well. Like so, to hold the two variables, first one the data part, and then the next pointer pointing to the address of the next node. So this is a whole node class which has two part. First one is the data, and then the class. So we will first implement the class of node. So what this will have, two parts. First one will be the value part. So for now, these both will be none, and then the next part, and this will also be none. So it is a very good practice to have a parameterized constructor in order to when we are going to create the class for this nodes, we don't have to sign the value one by one using this point and dot operator of this class object, and then use the dot operator, and then you assign the values. So instead of this, we will just create a constructor. What constructor will do, it will just at the time of creating the object, we can assign the value to this class. So it will take in two parameters. First one will be the for the value part, and then I'm assigning them the default values, which are none and none. So now self dot val you will be equal to val, and in our next part self dot next will be equal to the next part. So we are done with our node class, and so now we will implement our stack class. So starting with the keyword class, and then I will name my class as stack. So declaring the constructor. In this constructor, I'm going to create a variable which will be top. So this is going to be the single variable I'm going to have in my class. And what this variable will do, this will pointing to the head of the top element of the linked list I'm going to have in my stack class. So what does mean by linked list? This is node. The top element will be pointing to the node which will hold the top element value, and then the next part. So for now, as initially I'm just assuming that the stack is empty and there is no value. That's why the top element is pointing to null. But as we go on with our program, we will as I'm creating this push function, this push function will do this will just takes in the value which is going to be pushed into our stack. So initially we will check. There will be two conditions. First of all, the stack is empty. When the stack is empty, we have to push the element which is going to be pushed into stack. That element will be inserted at the bottom of the stack. So first of all, we have to check whether the stack is empty or not. So as I have assigned the value none to the top, so I will just check this condition. If the stack is none, mean there is no element in stack. So what I'm going to do is I will just assigning it a node class, and I will pass just a single argument which will be val. So what this line will do, this will assign our data member a node class, and in which I am passing a value. This value will be, this none will be replaced by this value, and this will be assigned to the value part. And then the next part, there is no parameter being passed, so this argument none will be assigned to the next part. So this part will have a data part, and there will be no next part. What does this mean is that this is the very last element in our stack. This is the first, and this is the last element in the stack. So now the list was empty, and then I have pushed the element, and that element become the last element of our stack. So in else part mean there is already a value present in the stack, and that value is on the must be on the bottom. So the newly inserted value must be on the top of the value already been stored. So what I will do, I will just create a temporary variable and assign it the node class and variable part. And in the second part, what I'm going to pass is our already top value. So but this line will do, this will create a node class into the temporary variable which has the value part, the value which has been newly passed on, and then the in the next part it will have our already existing value. For example, the top index has been pointing to the node which contains the value which has been inserted at the last. So in the next part of the temporary pointer, there is already stored, there is a link of the already stored values. So in the next part of this temporary pointer, there is a already stored a whole linked list. So what I'm going to do is just then assign the top my top variable this temporary uh, class object. So what this line this will move this will do, the temporary object has a class which has the value part, and then in the next part it has the already existing linked list. And then what I have done is that I have assigned the top value, that the class which has the top element in our stack. So now the stack has the top element, and then I made the top element equal to that temporary. So now the top element has the value that has been inserted at the loss. So basically now the top element is same as the temp. So the top element has the value part, and then the next part, and the next part it has the already stored uh, list we have in our class. So this was it for the push function. So now in order to assess the top, what we will do is just we will return the self dot top dot data. So the main objective of making these public function and this private, and I made this private because I don't want it to be assessed outside the class, but these values are going to be used in our stack class. That's why I have created them the public and created the private, because it's just going to be used in our stack class, and it should not be assessed outside the class. So this was the declaration and definition of the top function. This will just return the value, whatever value present on the top. So then at the last we have that push function, pop function, sorry. So what this will do is this will just move our top part to the very next part. So now the pop function was pointing, before calling the pop function, the top was pointing to the first element. So after, if I call the pop function, the top element will move to the top next part. For example, if it was pointing to the first node, then it is going to be pointing to the next part of that first node, which will be the second node. So the last function we are going to create is empty. So this will check if our top element is none or not. Uh, so if we just return the top element, now I have just returned this top element, and in the main in my main program I will just check this empty equal null or not. If this empty equal none, mean this there is no element stored in the stack. So now I will just create a object for the stack. So I will just call it as stack. So stack object has been created. So now I will call on the, I will just sign it a small letter. So stack dot first push, and I will push on a value 10, and then I'm going to call this function 2 or 3 times. So changing the values. So now what happened here is just I have just called on the push function 3 times. So the first value, which is going to the very last value in our stack, is 10. Then the value onward will be 20, and then the value present on the top will be 30. So if we try run this one, when the constructor is called, the object created, the constructor will be called, and the self.top will be have none value, mean there will be no node present in our stack. And then when the push function is called, the first this condition will become true. There will be none value stored at the top, so a value will be stored at the top, which will be the last value in our stack. And then when this value will come, this condition will become false, and this condition will become true. So a temporary variable will be pointing to this 20 value, and afterward in that node next part we have the already existing linked list. And then I have just changed the top element equal to that temp, so that our top keep updated. Let's keep pointing to the very first value of our stack. And then similarly the 30, when the 30 comes, this condition will also become true, and the same step repeats. So if I want to display the value of the stack one by one, so I'm just going to do is loop it through. So while stack dot empty is not none. So for as long as the stack is not empty, I'm going to print the value of the stack.top. Stack.top function will return the value, whatever value that on the top. So after then I will just call the pop function. Pop function will move the top to the next element. So if I go on and run this, so I have made a mistake here. This has the data part as value. So if I have just run this, and you can see the first retrieved value is 30, and then the retrieved value is 20, and then I have the value 10. So this was the basic implementation of the stack using the linked list in the Python. So in the next video we will cover the stack using the array part. So for then, goodbye.